Welcome back to Backspace Academy. In this video I'm going to give you some core knowledge that you will need for all of the streams of the AWS Certified Associate exams, and it will be on EC2, and I will be making sure that it will be as quick as possible and give you the maximum amount of knowledge in the shortest amount of time. So the EC2 instance types, so you need to know these. There's 5 of them, and you need to understand what they are and in what applications you would use them. So the first one, general purpose, so the name says it all. So it's a general purpose, has a good balance of compute and memory and storage. And that is generally used for, and there's some examples there, small and mid-sized databases for running SAP and SharePoint servers. Other enterprise applications, and the instance types there are T2, M3 and M4 is what they are called. The next one is compute optimized, so these are for compute intensive, CPU intensive applications, so for web servers for batch processing, for analytics and video encoding. So they're the C3 and C4 instance types. And then we have memory optimized, so that's going to be for high performance databases, for in-memory caches, for large deployments of SAP and SharePoint, and that's the R3 instance type. Then we have the GPU, so that's going to be for your graphics applications, so for 3D graphics applications, for machine learning and high intensive GPU compute workloads, and that's a G2 instance type. And then we have the 2 storage optimized instance types. So the first one being the I2, so that's going to be good for NoSQL databases and transactional type databases, Hadoop. And then the next one, which is going to be a large storage optimized instance type, which is the D2, and so that's going to be for data warehousing applications, for large MapReduce and Hadoop applications and the like. So that's not all of the EC2 instance types, but they're the ones that you would select for long-term support. So the older Virtual Machine instance type, they are also available, but it is recommended that you use the HVM, the Hardware Virtual Machine types are recommended by AWS for long-term support. So when you're selecting an Amazon machine image, and we'll talk about that in a second, always make sure that you select a HVM type, because that's going to be the one that's going to give you the latest EC2 instance types. So on your EC2 instance, you can have a choice of Linux or Windows and all of the variants around that. So one of the instance types that is quite unique is the T2 Burstable Performance instance. And this is a really good instance type to use for general purpose ERP, enterprise applications. So what it does, it has a baseline performance that you should aim to be under, but it also has the ability to burst outside of that baseline performance. And you're allowed to do that provided you have CPU credits built up. So CPU credits, they're built up and stored for up to 24 hours while that instance is operating below that baseline performance. And then as those credits are building up, if you need to burst above that baseline capacity, you're allowed to, and then you consume those CPU credits. So this is a really, really good instance to use for those ERP type applications, because, for example, you probably find that if you're just operating in one time zone, for example, and you've got a large ERP system, you'll find that when people log on for work, when people come to work at 9 o'clock in the morning or whenever they do, and they turn their computer on, they're going to want to log on to that service, and they're all going to want to do it at the same time. So you're going to have a big hit of capacity at around about 9 o'clock in the morning. And then at the rest of the day, you might be just operating below your baseline, and then overnight you'll be well below your baseline. So this enables you to, while you're, for the most part, operating below your baseline, and then overnight you're building up these CPU credits, come the next day in the morning, you'll have these CPU credits that will be built up overnight, all ready to go. It will allow you to burst above that baseline capacity. So one thing you need to keep track of, and you can use CloudWatch or whatever to keep track of this, is to make sure that you maintain a positive CPU credit balance to allow that bursting to occur. Otherwise, you're just not going to be taking advantage of this burstable performance instance, and you'll be better off, using another instance or use this same instance and upgrade it. So there are a number of EC2 storage options. So the first one being the instant store. So that is physically attached to the host server. Now, when the operating system is rebooted or that instance is restarted, data is not lost. So the data is maintained there, but you need to consider that data is definitely lost when obviously when an underlying drive fails, or if you have an EBS backed instance, if that is stopped. So if an EBS backed instance is stopped, then an instance store data will be lost. Or if an instance is terminated, then that instance store will be terminated with it and the data will be lost. So that's different to an elastic block store, EBS. So an EBS is a preferred one to use, and you would generally use that most of the time. So that is replicated within an availability zone, or within multiple availability zones. It's replicated within a single availability zone. And then we have the EBS optimized instances, and they can actually provide dedicated throughput between EC2 and that EBS volume. Now, EBS volumes, if they are attached when the instance is launched, they will be deleted when that instance is terminated, as opposed to when EBS volumes are attached to a running instance. So after you've run that instance and you attach it afterwards, they are not deleted when that instance is terminated, but they are detached with that data intact. So you need to take that into consideration, and you also need to know it for the exam as well. So you need to know when data is lost and when it is maintained. And it's very important as well with EBS volumes. So if you start attaching them after an instance has started running, then when you terminate that instance, you might think that you forget about the EBS volume, but you're still paying for that. So it's always good to do it at launch time. So the type of EBS storage options that are available. So we have general purpose solid state drives, which is a default choice for EBS. And then we have provisioned IOPS. So they give a consistent and low latency performance. So you define what those provisioned IOPS are. And they're suitable for IO intensive applications such as large databases. And then the lowest cost is going to be your magnetic EBS storage. And so that gives you the lowest cost per gigabyte. EBS snapshots. So you can do point-in-time backups of your EBS volumes to Amazon S3. And they're incremental backups. So as you keep backing up, it's not going to back up the entire EBS volume. It will only back up what has been changed from previous backups. And you can also take those EBS snapshots and you can copy them to other regions or even other AWS accounts. And also with EBS, you can encrypt your data at rest, including all of these snapshots. So if you encrypt an EBS volume, any snapshots that were created from that will also be encrypted. And you will also be encrypting the data both at rest and in transit between EBS and EC2. So you can use the AWS Key Management Service master keys or customer supplied or customer master keys can be used with that. So Amazon Machine Images. So they're what we use that to define what goes into our server. So it defines what the operating system is going to be. It's going to define what volumes we're going to have attached to it, and the mapping of those volumes. So it provides the information that we require to launch an instance. So it has a template for the root volume instance. So that means it's going to define, it's going to have a template for the operating system, an application server, or any applications. It will also have the launch permissions, which will control which AWS accounts can use that AMI and launch instance, whether it's a private AMI or whether it's a public AMI. And it'll also have the block device mapping, so it'll define what volumes attached to the instance when it's launched. So AMIs can be put on the AWS marketplace, and so they can be sold, or they can just be put there for free. So you can have paid AMIs on there that you can pay for and use. If you want to have an AMI to run SAP, for example, you can pay for that and pay by the hour on that. There are free ones, there are trial ones, and there are ones where you can bring your own software. So you might be running Windows Information Server and Internet Information Server, and you'll bring your own license for that, and you can actually do that. If you're running large distributed applications that have processes that are running across multiple compute resources, then you should consider taking advantage of cluster networking to improve the efficiency of that. Now, a number of EC2 instance types, generally the larger types, have enhanced networking capability. Now, that uses single root I/O virtualization, or SR-IOV, and that provides a higher I/O performance and a lower CPU utilization, and that is at no additional charge. Also, in those larger types of instances, there are also available EBS optimization or EBS optimized instances. And those instances are designed to deliver the maximum provisioned IOPS performance from your EBS volumes, and that will occur 99.9% of the time. If you're going to take advantage of this, then the best way to do that is to put your EC2 instances inside of a placement group. To create a placement group, it's quite straightforward. You just go into the EC2 console and go to the section on placement groups and just click on Create Placement Group. You give the placement group a name and you click OK, and that's all that needs to happen with creating a placement group. And then once you've created that placement group and it's up and available, you can then launch instances into that placement group, and they will take advantage of the enhanced networking to create a very high-speed, low-latency environment for those multiple compute instances. So placement groups, they provide a low network latency and a high network throughput. It's available for those instances that support enhanced networking. So if you go in and you create a placement group and then you launch an instance that has that available, it will be an option there that you can select to put that into a placement group. If, for example, you're launching a T2 instance type, which doesn't have enhanced networking, the option to launch into a placement group will not be available there for you. Placement groups, they cannot span multiple availability zones. They need to be in the same availability zones. They can span peered VPC, but they will not get the full bandwidth that you would get in a single VPC, in a single availability zone. Instances, they must be added only at launch time. So you can't launch an instance and then try and add it to a placement group after that. You need to go through, launch that instance, and then select the placement group to launch that instance into. And by the same reason, you can't merge placement groups. So if you've got an existing placement group, you cannot take the instance from that one instance placement group and put it into another. It won't allow that to happen. And you can't merge the two and create one either. But cluster networking is a very good option if you've got large batch type processes using very large compute resources that are distributed across, where applications are distributed across multiple compute resources. So the EC2 service, it was introduced in 2006, and in 2006 instances they ran on a single flat network which we now call the Classic Network, and that was shared with other AWS customers, so it didn't have your own virtual private cloud as such. So the VPC service, that was introduced in 2009, and instances do run in a virtual private cloud, and that is an environment that is logically isolated to your AWS account and is isolated from other AWS accounts. So all new AWS accounts must have EC2 instances launched inside a VPC. And new accounts already have a default VPC already set up. Now, old accounts, they don't have that old VPC set up, and they may still allow EC2 instances to be launched outside of a VPC, and I say may because not always. So they will only be allowed if they have previously launched an EC2 instance in that region. So if you've never launched an EC2 Classic instance in a region, you will not be allowed to launch it now, no matter how old your account is. If you've got a new account, you will never be able to launch an EC2 Classic instance. It will have to be in a VPC. So we need to know the difference between the two, because although it is not something that Amazon Web Services are going to be pushing in any way, there are old instances out there that may need to be supported and may not be able to, and old AMIs that may need to still use EC2 Classic. So you need to know the difference between them if you're using them, or if you're administrating them, or whatever you're doing. So with EC2 Classic, an Elastic IP is disassociated when the instance is stopped, whereas with EC2 VPC, it remains associated when the instance is stopped. You can have an unlimited number of security groups in Classic, whereas only 5 security groups in VPC. You cannot change the security group of a running instance with Classic, whereas you can with VPC. Security groups for Classic are for inbound traffic only, whereas for VPC you can have security group rules for inbound and outbound traffic. Instances in EC2 Classic can access the internet by default, so they're less secure than EC2 VPC, obviously. Whereas in VPC you require an internet gateway and a route to that internet gateway. With Classic, DNS host names are enabled by default, whereas with VPC they're not. And EC2 Classic only allows your instances to run on shared hardware only, whereas in VPC you can have shared hardware, or you can actually have single tenant hardware if you would like. So there's more details on that in the docs in the EC2 user guide under networking and security, Amazon VPC. So it's good to understand that table that's in there and make sure that you fully understand the difference between EC2 Classic and EC2 VPC, even though you may never run into an EC2 Classic instance. Okay, so I'm just going to show the difference between an old AWS account, and a new AWS account. So here's a reasonably new, only a couple of years old, this account here. And this is what your AWS account will look like if you've created one recently. So if you look at account attributes up here in the top right hand corner, you can see the supported platforms, VPC, and there is a default VPC. So you know just by looking at that you're inside a new type of account. It's not one that supports EC2 Classic. So now I go into another account, and this is an old account that I've had back from I think 2010 or 11 or something like that. And you can see here that the supported platforms are still VPC, but it's also EC2. So EC2 Classic is also supported on this account. But you can also see that there is no default VPC. So that's the main difference between an old account and a new account, is that there is not a default VPC, and you can launch into EC2 Classic only in a region where you have done that before. And so if I go in here and launch an instant, and I can select an AMI here, and that will have the full range of instances available of the modern type that are available. And you can see here I can only launch it inside a VPC. So there's no option there for EC2 Classic. Whereas if I go to an old account and I go to launch an instance, and and you can see there is an option for launching into EC2 Classic, but that option is being blacked out or greyed out for me. It's not available for me in the North Virginia region. It is available for me in the in the US West, I think it is. In one of those regions I have used EC2 Classic before, and it does allow me to do that. So there is the difference, that you can launch into EC2 Classic with an old account. So another really, really good service is the EC2 container service. So that's a pretty new service. Came out in, I think, mid-2015, I think. So what that enables you to do, it enables you to use Docker containers to launch or to define and launch EC2 instances. So a Docker container, so I've just taken this from the Docker website. So a Docker container wraps up a piece of software in a complete file system that contains everything it needs to run. So it includes code, any runtime that's required, if it's Java or whatever, system tools, system libraries, or anything that is installed on a server. And the good thing about that is it guarantees that it will always run the same regardless of the environment it's running on. So where this has been really helpful is in the past, before we had the EC2 container service, you would, if you wanted to actually go from your Git repository to your EC2 instances, you would normally have a startup script on those EC2 instances that would pull in your Git repository and update that on startup. So that would create it would work, but it would create issues at times with operability between your operating system and your application. You would also need to reboot your instances to run that script. So it worked, but it wasn't ideal. So this is really a much better option. So what you would do, you would start with your Git repository, or now if you're not a software developer, Git is a version control system where you store your code. And code commit is a Git repository that is supplied by or a service from Amazon Web Services, but there's also GitHub, GitLab, and Bitbucket and the like. So you can go from Git and then push that pull that in with the Docker command line interface, and then once you've Dockerized your application, it can then be taken across to the EC2 container registry, and that will store that there and then you can use that to push to an EC2 container service, and that EC2 container service will then launch EC2 instances, or if they're already launched, it will update those EC2 instances, and that includes all of the architecture around that. So it'll provision a virtual private cloud. It'll do elastic load balancing and the like. And so that is a very, very streamlined approach, and it's certainly, developers should be using that sort of approach. The EC2 container service is a great way to really integrate your code through to your EC2 services that are running. Okay, so let's have a quick look at the EC2 container service. So when you've never used it before, when you go to the, I'll just see, when you go here, services, EC2 container service. So when you go into there, it'll have the this getting started URL. So that URL only appears once. So if you want to get back and redo that, you can go to the getting started page on the EC2 website and or the EC2 container service website and do that again. So just when you start off here, so just click on Getting Started. And what I'm going to do is just run a sample application that AWS supplies, and what it does, it provisions a web server. But not only does it provision an EC2 web server, it actually does it within a virtual private cloud. It does it within or behind an elastic load balancer. It provides a launch configuration, an auto scaling service. It does a whole heap of stuff that would normally take a long time. So when you start to look more into architecture, especially if you're going into the solutions architect course, you can see that this EC2 container service does an enormous amount of stuff for you that is automated. So just clicking on here, Get Started, and I'm not going to store the containers images in ECR, but I could if I wanted to. So this is just going to run our Getting Started application, which is just a sample application. So deploy a sample application onto an Amazon ECS cluster. Okay, so I'm just going to click OK on all this. And that's fine. No problems there either. Actually, I'll just go back because what I'll do is I'll put an ELB, so elastic load balancer. I'm going to put an elastic load balancer on there as well, just to give it a whole heap of work to do. So just going to review and launch. And I'm going to launch and run this service. So it's just created the ECS cluster. The task definition has been created of what has to happen, and now we're doing all the EC2 setup work. So you can see here we're doing a cloud formation stack. We're going to be creating an internet gateway that'll connect into a VPC. We're going to have route tables, subnets, an elastic load balancer, security groups, different subnets inside of that VPC. An auto scaling group and a launch configuration, and it's all going to be managed with an elastic load balancer. So that's a hell of a lot of stuff going on, and if you wanted to do that manually, it'd take quite a bit of work. So in the Solutions Architect course, we do actually go through creating a similar sort of architecture to this, but it takes a lot longer than this. This just takes just a few minutes, and we're done. Okay, so thanks to the magic of pre-recorded video, we've fast forwarded through to this being done. Didn't take long, just a few minutes. So let's view the service and see what's happened. Okay, so we've got a cluster here created, and it's created. We've got a load balancer there. So there's our cluster. So if I go to the EC2 service, we should see that all happening. Okay, so we've got there one running instance. Okay, so we've got our running instance there. It's up and running, no problems there. We've got, let's have a look, we've got some volumes, have we? And we've got our volumes there. Let's have a look, we've got a load balancer, I think. Okay, so there's our load balancer. So everything's been set up, so that's pretty good. There's a lot of work that you would normally do that's all been done for us. So here's our EC2 instance, and we'll talk a lot more about EC2 instances. There's a hands-on lab coming after this where you'll actually get your hands on and creating an EC2 instance and launching that and connecting into it and all that. For now, I just wanted to show you the EC2 container service and how pretty cool it is. So what we've got here is a public IP. So let's have a look at that and see what's happening there. So we'll go to that. So there we have. So it's created a web server, and it's done it behind an elastic load balancer, which is inside a VPC with multi-AZ, different subnets. It's got the whole kit and caboodle. It mightn't be the most exciting web application you've ever seen, but the architecture behind that is quite fantastic, and it's done it all at just a few clicks. So when you're using your own code to actually go straight from your Git repository straight through to your architecture and have it up and running like this is a fantastic thing. And certainly if you're a developer, this is the way that I would recommend that you actually use Amazon Web Services.